Hello everyone, this is KP the Math G here once again. This is the 2014 free response question number 1, and this is actually the last part of that. I answered the first two parts, A and B, and then later on I did part C, and then now I'm at part D. And I'm trusting this is for the calculus students, and maybe for those who just might be interested in learning how to do this. Maybe it's a future AP student who wants to just look into this and see how all this is done. The question is talking about a problem dealing with grass clippings in a bin, and how that they decompose over a period of time after so many days. Well, after the t is between, it says for this t being between 0 and 30, including 0 and 30 days, the amount of grass clippings remaining in a bin is modeled by t is equal to 6.687 times 0.931 raised to the t, where A T is in pounds. This is amount, and T is measured in days. The D part of this has to do with a linear. We have to come up with a linear equation, and so for T being greater than 30, L at T, the linear approximation at T equals 30 is the better model for the amount of grass clippings in the bin. So use L at T to predict the time at which there will be 0.5 pounds of grass clippings in the bin. So keep in mind this is a linear approximation, so that's really one thing we need to look at. It is a linear approximation. Okay, so you kind of get that notion from the letter L, don't you? Okay. Alright, so anyway, t equals 30, so let's take a look at this thing here. Alright. Alright, for this one here, we know that we're trying to get, let's put down the problem A at T. A at T is equal to 6.687 times 0. I won't say that's a 931 raised to the t power. Okay, and alright, so what we have here is we're talking about at t equals 30. Alright, that would be in our case x, and then this part right here would be y. So really what we're looking at is a point. Alright, we need a point. Let's see. We know that this is actually t comma A at t. Alright. We also need the slope. We need the slope, and that is definitely a prime at t. Alright. Alright, that's what we're dealing with right there. It's been a while since I've looked at this problem. I wrote it down somewhere and I can't remember where I put it, but we can manage without it. We do know that y minus y1 is equal to m times x minus x1. In this case, we're saying y1 is A at t. Alright, x1 is just t. Alright, like that. And okay, like I know that doesn't look really as good as it should, but anyway, it's actually, well, t minus t1. So let's, instead of x, let's make it t minus t1. Okay, and this is sub 1 here. Okay, like that. Alright, so what we got to do is, we already know that t1 is 30. We need to find the slope right here. So this is actually a prime at t, like that. Alright, so a prime at t is the slope. So really we're looking at a prime at 30. We're looking at a at 30, a prime at 30. We already know 30 goes here, so we might as well just, but I will put it in there a little bit later, but that's the idea behind this. Okay, just get that idea. You need to think about y minus y1 is equal to m times x minus x1. And that's just the way it works out. You need a point. We already know that t is 30. We just got to find a at 30. And one way you can do that is if you go to, I've got y sub 0 on my calculator. If you have y1 and you put this whole thing in there like this, 6.687 times 0.931, alright, raised to the t, and then you call that up by y vars, okay, y vars, and the list is going to show you y1, y2, y3, y4. So you pick y1 and then put it in parentheses. You want to put 30 right there. Alright, so that's what you're really doing. So really what you have here is y minus a to the 30th here. That's t, that's your time. And then you want to find a prime at 30. And then this is equal to t minus 30 right here. Like that. Okay, that's really what you're doing. Okay, that's your slope. So y at 30, if you y1 at 30, in my case it's y sub 0 at 30, and I just moved my okay. Oh yeah, also we know that that's equal to 0.5. Okay. Let me see here. I did y at 30 before and I can't find it for the life of me. Let me see if I can find it here. I may just have to redo this, so let's do it. So I'm going to get into that y bar and I'm going to hit, in my case, y sub 0, and then I'm going to put 30 in here, like so. And that's going to be, okay, so this right here, and really you don't have to do that until the end, but I'm going to go ahead and do it now. And you just have to, it's going to be a rounded figure because it's a non-repeating decimal. 0.87 or 0.78 rather, 782, something like this, 927, and then 86938. 86938. I don't know if you need to go out that far anyway. That's y sub 1. You could probably cut it off at 7.783. Get away with that. That would probably be alright. I'm going to make it as accurate as possible. Now here, so in other words, this part right here is a so this is a at 30 right here, which is, alright, so a at 30. Okay, and then of course we need to find a prime at 30. Alright, so let's see, I can do that again, but I need to go to math and I want to find the derivative. Okay, and then I want to put in that, in your case, y1. And so what you have on your calculator, you can hit that, you can get, if you get this right here showing, and then you got this right here, you already have your y1, you can simply put y1 right in there like that, inside that parentheses, and then hit enter, and that will give you that. That's actually that, and then of course it's going to say x equals 30 like this. Alright, and so you fill that part in just like that, and you should be getting something like, so let me do it right quick. Let's see. Alright, so I've already had this done, so anyway. Alright, so that's a negative number, as it probably should be. Okay, so we have in this case this derivative here, y prime at 30, is equal to a negative 0.055 976 21228. 21228. Okay, that's what I have there. Okay, yes. Okay, and now I can use that. Okay, so let me put that into the equation here. Let's see if we don't have enough room. We may have to flip this over. So let's see. Y minus, and all of this right here, 0.782. I don't know how far out they go. They go on out to 82928. 82928. 2928. Actually, you can get the exact value. This is minus, not a negative. Okay. And that's equal to m, which we already know that. That's this. So a negative 0.0559, probably 976 is probably how far out they go with that. And yes, that's how far out they go with that. Okay. Alright, so it's equal to m times t minus 30. Okay. Okay, and of course we can actually solve for y. Alright, so let's see here. And let me see what I need to do here. I want to erase this at this point now. I already have this right here. I'm just showing you how you can go about doing that. Do I need this still? I don't know. Probably not. I might need this room over here. Okay, and I guess probably I should just go ahead and equal that so I can have some room here. Equals negative 0.055976. Very small slope, isn't it? Times t minus 30 right there. Alright. Alright, so, and of course, I want to say that we bring this over here to this side. We can do that. We'll have y is equal to, okay, and then if we bring this to the other side, that would be positive. So just know that when you bring this over, it'll be positive. So negative 0.055976 times t minus 30, and of course bringing this to the other side, 782,928 plus over here, so plus over here 0.782928. 2928. Alright, right there. And then of course we are going to solve this right here. We see that y is 0.5, and we want to find the value of t here. Okay. Alright, so that's what we're doing there. Okay. Matter of fact, we probably should have just left it over there. That would have saved us a little more time here. Alright, so back to that. Let's just subtract it and bring it back where it was. I don't know why I didn't do that. 0.78782928, alright, is equal to negative 0.055976 times t minus 30. I like to just go ahead and, if you want to, you can distribute that, but I think we'll just divide this side here like this, both sides, by negative 0.5976. I've got such a long number in front here, so I'm just going to simply divide by that, negative 0.055976. Now, I'm going to need a little more room here. That's all of this is equal to, I'm just going to erase this part right here since I got rid of it, just equal to t minus 30. Alright, t minus 30. Okay, now I'm simply just going to add 30 to both sides, so let's just go ahead and leave it like that, equals, well, right here, equals t minus 30. Add 30 to both sides, like that, and that should do it. And now we have t. Alright, so if I punch that in, let's see here what I get. I already have the answer to this somewhere up in here. Okay. Okay, that is going to be, alright, I have the answer, but let me do this by hand since I've already, alright, 0.5 minus 0.782928. Enter that amount. Alright, now divided by negative 0.055976. I want to enter that amount. Now I'm going to add 30 to that. That's going to be equal to 30.054. 35 rather. 35.054. It's equal to about, so t is about equal to, well, you might as well say it is equal to 35.054. There is a way, and this is the number of days, by the way, past when t is greater than 30. Well, okay, 35 days. Okay. Alright, and so that's at t equals 30. Alright, 30 days. Alright, so, well, actually it says how many days. Let's see, what does it say? Predict the time in days that there will be 0.5 pounds of grass clippings. So that's the number of days that it will be 0.5 pounds of grass clippings. So a little bit past 30 days. Alright, and that's really what you do. I'm telling you, I could probably do this. Let me show you something else. This is really a little bit crazy. Alright, I'm going to erase this answer here. I'm going to show you. I did it this way and got a more accurate answer. Of course, solving for y, I just simply, added, so plus, so let's see, I did it this way. I had to solve for t. So So yeah, it would be 0.5 minus a at 30 into, alright, divided by a prime at 30, and then of course plus 30 would be equal to t. And of course that derivative will show up down here. I do believe that's what I did on that. So yeah, you have to divide and then add 30 to that. Okay, that's really all there is to it on that. That's what you can do. Again, t is 35.054. Alright, 054. And that's in the number of days. Okay. Alright, that's how long it takes for there to be 0.5 pounds of grass clippings. Okay. I want to see if you know this. Y minus y1 equals m times x minus x1. Just remember, you need a point and you need the slope. And that's the key right here. This is it right here. If you understand this, you should be able to be alright. But I mean, this does take some thought. You gotta know, just think about it. If you're looking for an equation, you need a point and you need the slope, and this is how this is set up here. Okay, that's all I have for this one. Matter of fact, this is all done now. This is KP the Math G. Hoping that you have learned something from this. I'm getting ready to sign off, but before I do, please subscribe if you haven't done so already. Please make a comment if you would like to, and then of course hit that like button. I love those likes. That number of likes really looks good, and I do appreciate every one of you. I know some of you have already are through with the AP exam. You've already finished that on the 13th. So congratulations. I hope that many of you, that you all have done well on this, and maybe I've helped out some. I hope I have. But anyway, you know, if you don't do any of the likes or any of the comments or subscribe, that's all right. This is mainly about you and not about me. KP the Math G signing off. Ladies and gentlemen, have a great day.